Hello and welcome to this presentation related to an introduction to transposition. We're going to consider initially three variable transposition, for example Ohm's law, V is equal to IR, and show the various transpositions that can be performed. And then we'll consider slightly more complicated transpositions as shown by these formulae here. And for reference, most of the formulae we're going to transpose relate to electrical engineering theory. Presentation overview. A brief introduction related to transposition of formulae, also referred to as rearranging equations. We then consider inverse operations, such as add and subtract, also referred to as plus and minus, and multiply and divide. Multiply sometimes referred to as times. We then consider transposing terms that have symbols multiplied together, and then transposing terms that have symbols that are divided. We then outline a series of tutorial questions, question 1 to question 10, questions 11 to question 19, and questions 20 to 38. You'll find these questions within our workbook, but they are stated on the following slides. And here are the approximate start times related to the various sections shown on this slide, hopefully to aid your ease of access through the presentation. But please note these times are rounded to the nearest minute. The answers to all questions are shown within these sections. Presentation overview continued. So here are questions 1 through to 10. On the left hand side of the slide, we're given a formula, Ohm's law here, and we're required to transpose it initially for I and then again for R. Question 2 given, and again the same process, transpose for V, transpose for I. On the right hand side we have questions 11 through to 19. And again we're given a formula, in this case it's R is equal to rho multiplied by L divided by A, and rho is a Greek symbol. So currently R is the subject of the equation. We'll have to rearrange for rho first of all, and then rearrange for L, and then rearrange for A. And this is question 12 and onwards. And here are the approximate start times related to the selected solutions. So solution for question 3, 22 minutes into the presentation. For question 7, 24 minutes in. Question 16, 27 minutes. Question 17, 29 minutes. Again, these times are rounded to the nearest minute. Presentation overview continued, and here are questions 20 right the way through to 38. Again, for you to attempt at your own pace, transposing them to find the variable stated. And here are the approximate start times related to the final batch of selected solutions. Question 20, 21, 26, 27, 33, 34 and 35. All these questions have worked solutions commencing at the time stated, but again these times are rounded to the nearest minute. For your reference, within this presentation I tendency to use the terms formula and equation interchangeably, but formula relates to, for example, the volume of a sphere, V is equal to 4/3 multiplied by pi r cubed, which we could transpose or rearrange to make radius r the subject, whereas an example of an equation could be 3x is equal to 5 multiplied by in brackets 9 minus x, which we could rearrange and solve for the numerical value of x. So within this presentation we are essentially transposing formulae, but the same principles can be applied to rearranging and solving equations. So introduction to transposition of equations. Algebraic transposition relates to the transfer of one quantity or a symbol from one side of the equation to the other. The transposition process is required when rearranging a formula to make a particular variable or symbol the subject of the equation. So if we consider the standard equation for Ohm's law, V is equal to IR, V in this equation is classified as the subject of the equation, and the subject is usually written on the left-hand side of the equation. In this transposed form of the equation, we've got I is equal to V divided by R. Now I is classified as the subject of the equation. So in the first equation, voltage, V was the subject of the equation. In the second equation, I, the current, was the subject of the equation. One thing to remember throughout our transposition process is that the balance of the equation must be maintained at all times. Failure to do this will result in an incorrect solution. So in other words, whatever we do to one side of the equation, we absolutely must do to the other side of the equation and keep this inherent balance of a process. We'll show this process in the examples we're going to work through. So within this process, we're going to make use of the inverse operations technique to aid the transposition of equations. So for example, the inverse operation to addition, the add, will be subtraction, the take away. The inverse operation to subtraction, take away, will be addition, add. Now predominantly in this presentation, it's mainly multiplication and division we'll be using initially. Don't forget that the inverse operation to multiplication, the times there, is equal to division, the divide. The inverse operation to division is multiplication. So this process of inverse operations underpins all forms of transposition, however complicated they become. But we're going to limit our focus at the moment to mainly multiplication, division, and later on some addition and subtraction. So here are some examples where the terms are multiplied together. So in example 1 here, we're asked to transpose the formula V is equal to IR. Don't forget the I is multiplying the R there. If there's no symbol between the variables, then we assume multiplication, so that's I multiplied by R on the right hand side there. And we're asked to make R the subject of the equation. At the moment V is the subject of the equation. And this is the standard electrical equation, Ohm's law. V is voltage, I is current and R is resistance. It may be that we actually know the current and we know the resistance of the circuit, so we can quite easily find the voltage from V is equal to IR. But if we had a situation where we know the voltage and we know the current and want to find the resistance R, we would have to transpose the equation. And that's the reason why we're undertaking this process. So given the original equation, V is equal to IR, the first thing I do is to try and remove the I from the right hand side of the equation. Now this is where the inverse operation process comes in. At the moment the I is multiplying the R, so the inverse operation is to divide. So on the next line I'm dividing both sides by I. So on the left hand side I now get V divided by I, and on the right hand side I end up with R, and the I is cancelled on the right hand side here. All I've done on the final line is turn the equation around to show that the subject is on the left hand side, because that's the convention, so therefore R is equal to V divided by I. If I just show that process in a little more detail over here, if I commence with V is equal to I multiplied by R, I'll put the multiplication symbol in here, and I want to find R as my subject of the equation in this case, then as I is multiplied by R, the inverse operation is to divide by I, and that will leave me with R. So in other words, what I'm doing, these are my sort of thinking steps here effectively. I'm going to divide this side here by I, but if I divide the right hand side by I absolutely must divide the left hand side by I to keep what's called the balance of the equation. Now what you see here is that the I on the right hand side is cancelled because I divided by I is 1. Okay, just as 10 divided by 10 is 1 and 25 divided by 25 is 1. So I divided by I is 1. So on the right hand side I actually get 1 times R. So on the next line basically I've got V upon I is equal to 1 multiplied by R. But of course that's basically R. And all I do then is to turn the equation around to make R the subject of the equation. So R is equal to V divided by I. That's what gives me the final answer here. Okay, so that's my thinking steps there. You don't need to write it down like that, but that's actually the process I'm thinking through to do the transposition. If we take illustration 2, shown here, we're asked to make h the subject of the equation, and the equation given is v is equal to pi multiplied by r squared multiplied by h. That's actually the volume of a cylinder formula there. And this kind of relates to a problem I had in industry years ago, where I was given in the specification the volume of a cylindrical tank. I was given the diameter of the tank so I could find the radius, but I wasn't given the height. The height was a variable. Within reason, I could make the height of the tank whatever I wanted it to be. So I had to rearrange the equation for h because it was the only unknown. I knew what v was, I knew effectively what r was, but I didn't know what h was. And this is the kind of transposition I had to undertake to find the height of the tank. So given the equation v is equal to pi multiplied by r squared multiplied by h, I need to rearrange the equation to find h. Now, because all the terms are multiplied together, I can simply divide throughout by pi r squared. If I divide both sides by pi r squared, I will end up with h on the right hand side, but I'll end up with v divided by pi r squared on the left hand side. So that's now equal to h. And again, I just turn the equation around to make the subject on the left hand side. So h is equal to v divided by pi r squared. Now again, if I go through sort of thinking steps here, I started off with v is equal to pi, and I'll label this is multiplied by the r squared, it's multiplied by the h. So as the pi and the r squared are multiplying the h, the inverse operation is to divide. So I would divide by pi multiplied by r squared, but of course I must remember to also divide by pi r squared on the left hand side. So again, what happens on the right hand side is the pi r squared on the top cancels the pi r squared on the bottom to give you 1. So on the next line I end up with v divided by the pi r squared on the left hand side, and that's basically equal to 1 multiplied by h here. Again, just turning the equation around to make the subject on the left hand side, that's h is equal to v divided by pi r squared. And again, I end up back with my final form here. Just as a note on that question, some students get confused with the r squared term. They feel they have to do something with the square, they have to square root or something like that. But in this particular case, because we were trying to find the h and the square is on the r, that didn't affect us. The r squared remained as the r squared term in the final transposed form. We'll look later on at transposing that kind of equation for the squared term. And a couple more examples here. This is where the terms are divided together. So in item 3 here, we're asked to transpose the equation x is equal to y divided by a, and we've got to make y the subject. At the moment, x is the subject of the equation, so x is equal to y divided by a. Now in this case they're asking us to find the y, and y is already in the top line on the right hand side of the equation. So if the a in this case is dividing into the y, then the inverse operation is to multiply both sides by a. And that's what's happened here. I've got a multiplied by x is equal to y, and I just turn the equation around again to get the y on the left hand side is equal to ax. Again, if I do my little thinking steps over here, I start with the equation x is equal to y divided by a. So in this particular case, as the a is dividing into the y, the inverse operation is to multiply. So I'm going to multiply the top line on the right hand side by a to cancel the a's. But of course I must remember on the left hand side to also multiply that by a. So on the right hand side, the a divided by a cancels to give me 1. And I end up with ax is equal to y multiplied by 1. And I just turn the equation around here, so y is equal to a multiplied by x. And again, I end up with my final solution here. And the final illustration 4 here, we're asked to transpose the same equation again, x is equal to y divided by a, but this time we've got to make a the subject of the equation, so a slightly more complicated process involved. So commencing from x is equal to y divided by a, in this instance I want to make a the subject of the equation. Now a at the moment is in the denominator on the right hand side, it's in the bottom line of the equation, and to be the subject it needs to be in the top line. So in this particular case, the first thing I'm going to do is to multiply both sides by a. At the moment, the a is divided into the y. So to remove it from the right hand side, I'm going to multiply the right hand side by a, and that means I have to multiply the left hand side by a. So a multiplied by x is now equal to y. So that's not actually the finished solution there, because I don't want a multiplied by x as a subject, I want a. So I need to now remove the x from the left hand side. And how do I do that? Well, I divide both sides by x. At the moment a is multiplying the x, so the inverse operation is to divide both sides by x. So I end up with a is equal to y divided by x is my final solution. So an extra step required there, because the variable we're looking for as the subject is actually in the bottom line of the original equation. So the first step I used there was to get it into the top line of the equation and then rearrange from there. So again, if I go through some thinking steps over here, I'm starting with x is equal to the y divided by a. So the question wants me to rearrange the equation for a. So at the moment the a is in the bottom line, so a is dividing the y, so if I multiply the right hand side by a, and of course multiply the left hand side by a, what will happen now is the a's will cancel again on the right hand side, and that will leave me with 1, and I'll end up with the expression of ax is equal to y multiplied by 1, as I had in the previous example above. But in this case that's not the finished form. I need to now rearrange the equation to find a on its own. So a is multiplying the x, and the inverse operation in this case will be divide. So now I'm going to divide both sides by x. So a multiplied by x divided by x is equal to y divided by x. Again, I'm keeping the balance. I'm dividing the left hand side by x, so I must divide the right hand side by x. These are my thinking steps. You don't need to write these down, but that's what I'm thinking in every step of the process. So now we can see on the left hand side that the x divided into x, that will be 1 again. So I'll end up with the final solution on the left hand side of a multiplied by 1, or simply a, is now equal to the y divided by the x. And that was the final solution we were looking for. So there's some examples of basic transposition of 3 variable equations predominantly here we're looking at. So on the following slide we're going to look at some questions, and I'm going to work through some of them on the board here for your reference. Okay, here's some questions for us to review. We're asked to transpose the following equations, making the value in the brackets the subject of the equation. So for example, in question 1 here we're given the formula v is equal to IR, and on this right hand column here it's asking us to transpose to find first of all I as a subject and then R as a subject. So there's 2 little questions there effectively. In question 2 here we're given the formula power is equal to voltage multiplied by the current here, and again we're asked to rearrange the equation to make V the voltage the subject, and then also to rearrange the equation to make I current the subject. So again there's 2 little questions within that question. In question 3 we've got power is equal to the current squared, I squared, multiplied by the resistance R, and we're asked to rearrange the equation to make I the subject and then to make R the subject, and so it goes on with all the questions. So there are 19 questions here for you to attempt. If you think you can attempt these questions without further assistance, then please stop the video now and attempt the questions. The answers are shown on the following slides, but if you want further assistance, then later in the presentation I will work through some of the questions on the whiteboard for your reference. Just note in some of the questions Greek symbols are used. This is actually the Greek symbol rho. This is the Greek symbol theta, Greek symbol capital Phi, Greek symbol mu, again Greek symbol theta is used again here. So in some of these instances we're using Greek symbols, and also note we have squared terms in the question and we're rearranging for that particular variable, such for example rearranging for v here in question 4. We will have to use the inverse operation to square, which will be square root of course. Here are the solutions. The questions 1 through to 10 here. If you take question 1, we were given the equation v is equal to IR. We were asked for 2 solutions. We were asked to find first of all I, and the solution for that is I is equal to v divided by R. Then we were asked to find r as a subject, and the solution is r is equal to v divided by I. Notice in question 3 here we were given p is equal to I squared r. We were asked to find first of all the subject of I. So notice the solution here, I is equal to the square root of p divided by r. So the square root is the inverse operation to square. When we were finding r as a subject, then r is simply equal to p divided by I squared. In question 9 we were given w is equal to v multiplied by I multiplied by t. So this time we were asked for 3 various transpositions. The first to make v the subject, shown here. The next to make I the subject, shown here. Finally to make t the subject, and that's the solution shown here. And further solutions shown here for questions 11 through to questions 19. Solutions on the right hand side here. Here are some further questions to attempt. We're asked to transpose the following equations. This is questions 20 right the way through to 38 here. In question 20 we're asked to rearrange the equation for r only, and in question 21 for d only. But in question 22 we're back to finding 2 solutions again, one in terms of L and one in terms of little b. Again, if you think you can attempt these questions without further assistance, I would encourage you to stop the presentation and do so. The answers are shown on the following slides. And here are the solutions to question 20 through to 30. Solutions shown in this column here. And here are the solutions for questions 31 through to 38. And again, solutions shown in this column here. Okay, what I'm going to do now is just to work through selected questions, just to show you my solution sequences. Question 3, which was p is equal to I squared multiplied by r. Don't forget we always assume multiplication if no symbols given between the terms, so that is I squared multiplied by r here. So for the first part of the question I'm going to make r the subject of the equation. So at the moment the I squared is multiplying the r, so my inverse operations would be to divide both sides by I squared. So on my next line, dividing both sides of the equation by I squared, I get p divided by I squared is equal to r. So I multiply both sides by I squared, but the I squared cancels on the right hand side and it crops up on the left hand side. Just turning the equation around, so putting the subject on the left hand side, r the resistance is equal to p, the power in this case, divided by the current I squared. If I now take the same equation, p is equal to I squared r, but I want to make I the subject of the equation, we need an additional step here. To make I the subject, the first thing I need to do is remove the r from the right hand side, so I'm going to divide both sides by r. At the moment r is multiplying the I squared, so those big dots are used for multiplication. So r is multiplying I squared, so to get rid of it, the inverse operation is to divide by r. So next line, dividing both sides by r, I will get p upon r is equal to I squared. So on the right hand side I've got I squared, I don't want I squared, I want I, so I need to square root the right hand side, which means I must also square root the left hand side. So my next line would be the square root of p divided by r, and that's equal to the I. Just note what we have done here, we have square rooted the I squared term. So the inverse operations, that's where we get the I from. All I do on the final line is to turn the equation around, so therefore I is equal to the square root of p divided by r. Going to consider question 7 now. We're given that w is equal to c multiplied by v squared divided by 2. In the first instance I'm going to make c the subject of the equation. So this time I've got c multiplied by v squared, I'll put a big dot for multiplication there, and it's all divided by 2. So I have two steps here to get c on its own. I need to remove the v squared from the right hand side of the equation, and I also need to remove the 2 in the denominator from the right hand side of the equation. So on my next line, to remove the 2 at the moment is dividing into the c, so the inverse operation is to multiply. So I multiply both sides by 2, so 2 multiplied by w is equal to c v squared. But that's not what I want just the c on its own. The c is being multiplied by the v squared, so on my next line I will divide both sides by v squared. So 2w divided by v squared is equal to c. So there's my solution. Took me 2 steps there. I multiplied both sides by 2 and I divided both sides by the v squared. So that gives me c is equal to 2w upon v squared. You could do both steps at once. You could multiply by the 2 and divide by the v squared all in the same step if you wanted to, but I've just done it step at a time here to show the process. Back to question 7 again. Given w is equal to c multiplied by v squared divided by 2, but this time I'm going to make v the subject of the equation. So following the steps through on the previous slide, I can multiply both sides by 2 to begin with. So 2w is equal to c v squared, that's c multiplied by v squared. This time I want to make v the subject, so I need to remove the c from the right hand side. So as c is multiplying the v, I now will divide both sides by c. So my next line is 2w divided by c is equal to v squared. But of course I do not want v squared, I want v. The question asks me to make v the subject. So now I need to square root both sides. So my next line would be 2w divided by c, and I will square root that term, and that's now equal to v. All I do is finally turn the equation around to make v is equal to the square root of 2w divided by c. So in every question and every step I'm considering inverse operations. Question 16, we're given that h is equal to I multiplied by n divided by L. It's very similar to the previous question we looked at. First of all, I'm going to make n the subject. At the moment the I is multiplying the n and the L is dividing into the n. So I could, if I wanted to do both steps at the same time, I could multiply both sides by L and divide both sides by I. So my next step could be L multiplied by the h and all divided by the I is equal to n. So I did 2 steps at once there. Because the I is multiplying the n, I can divide both sides by I. So that's why I crops up at the bottom on the left hand side here. And because the L is dividing into the n, I can multiply both sides by L to get the L on the top line on the left hand side. Just turning the equation around here to get the subject on the left hand side, n is equal to the LH divided by the I. If I now consider the same equation, but this time I want to make L the subject of the equation, then because L is in the bottom line on the right hand side and I need it to be in the top line to be a subject, the first thing I think I would do here is multiply both sides by L. So I will get L multiplied by h on the left hand side is equal to I multiplied by n on the right hand side. And finally, to find L as a subject, I now will divide both sides by h. At the moment the h is multiplying the L, so the inverse operation is to divide. So dividing both sides, in this case by h, I end up with in divided by the h. And that's in the right format. I've got my subject on the left hand side of the equation. Question 17, we're given E is equal to B multiplied by L multiplied by R, and it's multiplied by sine theta. Initially they want us to make B the subject of the equation, so as the L, the R and the sine theta, don't forget sine theta is all one function here, is multiplying the b, we simply divide both sides by the L, R and sine theta. So E divided by, on the left hand side, the L, R and the sine theta is equal to B. Simply turn the equation around. Taking the same equation again, this time we want to make R the subject. Then again, as all the terms are multiplied together, we can simply divide both sides by the BL and the sine theta. So in this case we will get E divided by the B, the L and the sine theta, and that will be equal to R. Let's turn the equation around. Again, considering the same equation, but this time we want to make sine of angle theta the subject. Again, as B is multiplying the L, L is multiplying the R, and R is multiplying the sine theta, we can simply divide both sides by B, L in R. So left hand side E divided by B, L, R, and that's equal to sine of angle theta. Turning the equation around, therefore sine of angle theta is equal to the E divided by B, L, R. And just for reference here, this is something we'll look at in further work. If we wanted to find angle theta instead of the sine of angle theta, the inverse operation for sine theta is actually the arc sine, or sometimes written as sine to the negative 1. And that would be of the E divided by B, L and R. But don't worry too much about that. That's just an addition to the actual questions we're looking at here. Some of you may have come across that inverse function before, but this is why I'll mention it for reference in this particular case. This is the actual correct solution for the problem we're looking at. Let's consider question 20. We were given the equation C is equal to 2 multiplied by pi multiplied by r. That circumference of a circle is 2 multiplied by pi multiplied by the radius of the circle. In this particular question we're asked to find the radius as the subject. At the moment the circumference is the subject C. So to rearrange the equation, we will simply divide both sides by 2 pi. Don't forget there's 2 multiplied by the pi and it's multiplied by the r there. So dividing both sides by the 2 pi will give r the subject. We just, again as always, we write the equation the other way round. So C divided by 2 pi is the answer there. Question 21. We're given the formula for area of a circle in terms of diameter. A is equal to pi multiplied by the diameter squared divided by 4. You're probably familiar with the formula pi r squared. That's the area of a circle in terms of the radius. This is in terms of diameter, so pi d squared upon 4. We've got to make the diameter the subject. And often in mechanics we might want to find the diameter of a section, knowing the area of a section, the area of a structural member. We want to find the diameter of the member, so we've got to rearrange for d. So in this case the pi is multiplying the d squared and the 4 is dividing, so I could on the next line multiply both sides by 4, divide both sides by pi, so I would have 4 multiplied by a divided by pi is equal to d squared. So doing 2 steps at once effectively there, but of course it's not d squared I want, it's actually the diameter, so the inverse operation to square is square root, so square rooting both sides, so 4a divided by pi is equal to d. As always, just turn the equation around, therefore the diameter of the circle is the square root of 4a divided by pi. Question 26. We're given the equation that E is equal to I divided by h squared. We want to make h the subject in this case, so as h squared is dividing the I want to get h into the top line, I'm going to multiply both sides by h squared, so E multiplied by h squared is equal to the I. But I don't want E times h squared, I just want the h. So the first thing to do is to get rid of the e from the left hand side. So as e is multiplying the h squared, I'll divide both sides now by the e. So on the right hand side I get I divided by e. Of course I do not want h squared on the left hand side, I want h, so I'm going to square root now both sides of the equation. So the square root of I divided by e on the right hand side is equal to h. Question 27, given the equation e is equal to I multiplied by cos of angle theta, and that's all divided by d squared. In this case I want to make little d the subject of the equation, so I need to get d on the top line. So my first step here will be to multiply both sides by the d squared. So e multiplied by d squared is equal to the I multiplied by the cos of theta on the right hand side, and divide both sides by e on the next line. So d squared is equal to I multiplied by cos of angle theta, and that's all divided by, in this case, e. And finally, to find d, I need to square root both sides. So we've got d squared on the left hand side, so inverse operation to square the square root. So finally d is equal to the square root of the I multiplied by the cos of angle theta, and that's all divided by the e in this case. Question 33 here. We're given the equation XL, that stands for reactive inductance, is equal to 2 pi multiplied by the FL. I'm going to make F the subject of the equation. So on the right hand side I've got 2 that's multiplying by the pi is multiplying the F is multiplying the L. They're all multiplied together here. So we're just going to divide throughout by 2 pi and L. So on the left hand side I'll get XL divided by the 2 pi L, and that's equal to F, and so therefore the F is equal to the XL divided by 2 pi L. Question 34. We're given XC, that's reactive capacitance in electrical work, is 1 divided by 2 pi FC. Again, on the bottom line we've got 2 multiplied by the pi is multiplying the F, and F is multiplying the C. We're going to make F the subject of the equation. So as the subject I'm looking for, F is in the bottom line on the right hand side. The first thing I'm going to do is multiply both sides by F to get the F into the top line. So on the left hand side I'll have XC multiplied by F, and that's equal to 1 upon 2 pi C in this case. But I don't want XC multiplied by F on the left hand side, I simply want F, so I need to now divide both sides by the XC. So therefore my frequency F is equal to 1 divided by 2 pi C XC. Just for the reference here, of course, it doesn't matter which way you write this on the bottom line. I could have had 1 divided by 2 pi XC multiplied by C. It doesn't matter which way round you write those. It doesn't make any difference in this case. Question 35. We're given Vp divided by Vs is equal to Np divided by Ns. This could be V voltage in n number of turns on a winding, for example. So in the first instance, let's find the Np as the subject of the equation. So at the moment on the right hand side, the Ns is divided into the Np. So to remove the Ns from the right hand side, I'll need to multiply both sides by Ns. So on my next line, I will get Vp multiplied by Ns, and that's divided by Vs, and that's equal to Np. So multiplying both sides by ns there leaves with np on the right hand side. As always though, to make it the subject, we put it on the left hand side, just turn the equation around. So Vp multiplied by ns divided by Vs is equal to Np. We consider the same equation, but this time I want to make Vs the subject. So Vs is in the bottom line on the left hand side. I want to make that the subject, so the first thing I need to do is to get it into the top line. So I'm going to multiply both sides by Vs. So Vp is equal to Np multiplied by Vs divided by Ns. That looks even worse than what I started with, you could argue. I've got more terms now associated with the Vs. But now I've got the Vs in the top line, I can now multiply both sides by Ns and divide both sides by Np to leave me with Vs. Just turn the equation around. Just as an aside here, you could actually write this equation in this form of Vs divided by Vp is equal to Ns divided by Np. So from here it's easy to transpose the equation. To find Vs, I simply got to multiply both sides by Vp and I've got my solution for Vs. But you need to be careful because not all equations can be turned upside down as I've shown there. I hope this has been of interest to you and thank you for viewing.